you ask this as a first question. Load the data and show the head of, show the load the data and tabulate the head of the records. And print the shape. So whenever you load any spreadsheets to do analysis, it's very important to understand the structure of the data. So this is the complete spreadsheet. It has 919 rows and 16 columns. Okay. So instead of writing a code in Python, of course, it is going to do the same Python coding, loading the data and to display. Even you can corresponding Python code also parallel you can get it. So if you wanted to do some interesting analysis, say for example, there are so many features, and the last column here is NUM is the different the level of chest heart disease labeled like 0, 1, 2 like this. If you are curious about how many labels are there in the last column, this is just only the first 5 records. Okay, let me ask the category of heart disease is shown in last column num. Can you show the value counts of it? Typically in Python, we do the value counts, right, for the categorical columns. Look at this, how many categories we have? 0, 1, 2, 3, 4. Severity of the heart disease. Okay, 0 is no. Okay, from mild to severe, 1 being the onset and 4 being the severe. Okay, some analysis, let us say if you wanted to club 2 categories into 1 category. See, this is just an imagination only. Whenever you do such analysis, you have to interact with the client to know the domain knowledge. Okay, without domain knowledge, it's very dangerous to draw insights from that data, whether it's a healthcare or it's a finance, whatever the data you are working with. Assume that your client is saying that, hey, mostly we give the similar treatment for category number 2 and category number 3. Okay, let us combine these 2 categories and keep it as 1 category. So this is no heart disease. Okay, this is just an onset. Okay, onset, this is a mild, and the 4th one we want to keep it severe. So you have to do a few steps in Python coding. Okay, here we can do it smartly. If you wanted to know the corresponding steps involved in the Python, you can see how df.num column value concept is done. The respective Python code, if you click here, you can see the coding also. Now what I'm going to do, consider category 2 and 3 into single category as 2. Okay, 2 and 3 we are going to combine into single category 2. And update the data 1, 2, 3. Okay, update the data with 4 categories from 0 to 0, 1 to 0 to 3. 4 categories. So 0 remains 0, 1 remains 1, 2 and 3 is going to combine to 2, and 4 becomes 3, isn't it? So consider category 2 and 3 into a single category as 2 and update the data with 4 categories. You can be very specific, 4 categories. Okay, we have given a very clear instruction. Now you can see earlier it is 109 and 106. Now it's combining this, adding 109 and 106. Now you have 215, merging the original categories 2 and 3. Okay, if this is a requirement, you have to do it. Okay, simply without knowing the domain knowledge, we cannot play around with this. Now we have 4 categories, right? I wanted to do some analysis like how age factor affects the disease. I wanted to know, okay, how the age factor affects the disease. So age is a continuous variable, and this is category is a categorical variable. I would like to, okay, otherwise better I will. Fine, age itself, let me take. Show the category wise box plot. You can be very specific. So you need some basic data science knowledge to pass the instructions. Okay, one is a categorical, another is a continuous value. Box plot is the best way to represent the visually, right? So I say show the category wise box plot with respect to age. So the updated num, we have 4 categories, right? You can see the range of age groups. What is the median age in each category of the disease? This is the mean age is around, median age is close to 50 years, 50, 51. Can you see the age is increasing? For the mild heart disease, the mean age is somewhere close to 55 and median value is somewhere close to 59, and this also very close to that. Also, you can see the minimum to maximum age groups. So the severe heart disease, there is no youngsters, right? You could see there is no youngsters. These are the extreme values beyond the 1.5 IQR from the Q3. Okay, Q3 to 1.5 times IQR. Again, Q1 to 1.5 times of IQR. Beyond that, we generally treat as an extreme values. Those extreme values are marked over here. So it's going to give a very clear insights. Okay, what age group, different disease category exposed to. Also, I wanted to explore about the gender. What type of disease? Because gender is a category and disease also a category. Which is the best way to explore these two columns is, I'm going to say, can you show the cross tab analysis between gender versus num? Okay, cross tab analysis. Because both are category means you need to do the cross tab analysis. My cross tab analysis is giving this report. If you want to give inference, you can also say that can you provide brief inference based on the cross tab. By looking at the number itself, you can comprehend, but just for the documentation purpose, if you want, you can make that inference or insights. You can see predominantly male cases are dominating in all category diseases. Can you see 26 males in a very severe category, only 2 females, 197. So again, the total number of males is high when compared to the female, total number of females. So that also matters. So the clear way for the clear interpretation, we need a proportion instead of this count. So before I take, okay, can you provide brief inference based on the cross tab in terms of, okay, instead of counting, I wanted to tell in terms of proportion, so that divide by the total number of male, you'll get it in the percentage. Because when I present in percentage, that will be a better insights than a count. So brief inference based on the cross tab in terms of proportion. So it is going to give you in percentages. Okay, what percentage of male and what percentage of female in each category. Okay. So can you see the male patients? The male patients and the female patients. The severe heart disease category, okay, 26 out of 725. This is 2 out of 194. That means 1%. 1% is female, 3.6% is the male. So male is dominating. Again, the moderate heart disease, 27.2% is male, only 9.3% is female. A mild also male is dominating. So across, you could see that male are highly affected by cardiovascular disease compared to the female, to the context of this data set. And the overall healthy, you can see 74% of the female are healthy, but only 36% of the male are healthy, no heart disease. So these are all the observations are being summarized over. Female patients have significantly higher proportion in the no heart disease, obviously. Severe heart disease category 3 is relatively rare in both genders, but slightly more common in males. Moderate is having male patients have more even distribution across the category, with notable proportion in the mild to moderate heart disease is slightly higher. So these kinds of insights, okay, it's quickly possible with a powerful data analysis tool. And for each step, you can see the corresponding Python code also at every steps. Shall we do some interesting a scatter plot? Two continuous variable will take and we do a scatter plot. Shall we do a scatter plot between age and cholesterol level? Okay, we'll ask, can you show a scatter plot CHOL versus NUM, right? Sorry, age. Also, I'm going to give additional instruction. Color code the data points based on num category, so that parallelly we can understand which category is spreaded in which position, which locations. So can you show a scatter plot of cholesterol versus age? Color code the data points based on the num category. So you can maximize this. So the yellow data points is category 3. Okay, this yellow data points. And category Z, this purple. So light green for 2. And for 1, again, this is a light purple and this is dark purple. It's a scatter plot. But here, just for the sake of scatter plot, I have shown, but not much information we gain from this. So likewise, you can do the exploratory analysis, and you can give a complete insights about this data, and you can give how each variable is affecting the heart disease. Like feature wise, you can compare which variable is affecting, and also you can draw the inferences also.